we want to talk, this is just an introduction to WinCC OA. What I'd like to do is walk you through the creation of a project from beginning to final runtime within a web client and see what that looks like, and use some of the predefined objects and predefined graphics that come with the WinCC OA environment. So what we will do is actually create a very simple pump station, 2 pumps, 2 check valves, animate these, and deploy these into a runtime web client, or web server, I should say. So let's get started. The installation of WinCC OA, with the installation, I should say, of WinCC OA, we see, oh, nope, sorry, wrong one. We see that there are really only 3 major components that get installed under Siemens automation. And that is, I have a few different versions here, the WinCC OA documentation, the help file, the project administrator, and the console. We're going to start this demo by launching the project administrator. From here, we'll create a brand new project. Note the folder it gets created in. So what this is doing in the background, I'm going to say no to that one. What it's doing in the background is actually creating a project folder, as well as a standalone database that all of the configurations and current snapshot values will be contained within. Now, I did mention that I'm going to use all of the predefined and reusable engineered objects inside the OA environment. There's one thing, I'm going to add a few outside third-party pictures into this to make the flow a little bit more presentable to the operator. So once the project is created, we launch it. And I may run a little bit long on this. I'm going to apologize, but I think it's important to see everything. And in the background, the system is creating the directories and creating the archives, the user archives. There's no password on the the root user. So here we are. This is our graphical editor environment, the Getty. We're going to create a panel, which is the operational interface. It's what the operators will see during runtime. And it's an object. It has properties and methods associated with it. We can change the panel size. Now, we have a simple panel. What we're going to do is add pumps and check valves to this overall lift station and assign those to a data point that leverages the predefined data point types within the OA environment. And how do we do that? To see the graphical objects, we're going to enable that view, catalog for all objects. This is a dockable interface panel. And from here, we'll open up the standard objects tab and add a simple pump. Now, I mentioned there will be 2 pumps. This interface, we can either choose to select a predefined IO pump, or I should say data point, or we can generate them from here. Let's go ahead and generate those. The station 1, pump 1. I'm going to have 2 pumps in general, or I should say for this runtime station. And they will be a data point type pump 1. So we have list station pump 1. We'll generate 1 more. LS1 pump 2. With this graphic, we will associate it with pump 1. And now we're going to parameterize these things. So what do I want to have enabled during runtime? Well, we need to know, is it open or closed? Let's go ahead and add some alarming attributes to that as well. If we wanted to, we could show the speed of the pump. In this case, pump is on. And then we need to do the same kind of parameterization for pump 2. I created it using a different pump type, you'll note. So we'll add a couple of different values, and then here's our state. Okay. And then from here, I can drag another pump on, link it to pump 2. That's all we need. The other thing we're going to do is create a check valve. And for this, we're going to use an internal data point to monitor statuses as well as alarming attributes. So we will generate LS1 P1. So lift station 1, pump 1, valve 1. To simplify our naming, we'll generate one more. Lift station 1, pump 2, valve 1. And again, we need to parameterize these things. What do we want to see? Do we want some alarming associated with that? We have to do that not only for valve for pump 1, but also the pump 2 valve. And we'll only have just a state on that one. Okay, well, let's collect. What I want to do with this valve is rotate it as well. And then connect it with a pipe. We can line everything up. And now with these two objects, we can copy them. These are just standard Windows keys controls. And in this case, we actually did it with all of them, so I don't need pump 2 here. I can change the attribute or the parameterization. LS1 pump 2, LS1 pump 1. You can do the same thing with the valves. Pump 2, valve 1. And now for a script I'm going to enable on a switch, I need to make sure my naming conventions are correct for these. Pipes. Actually, we can go ahead and align everything on the bottom. All right. I need to add one more exit pipe here, and that'll be here. And then you can squeeze these things up into there. So we have the exit header, feed pipes. That looks good. Let's add a, so one of the other things we need to know about a lift station is level. What is it? How full is it currently? So let's add another object here, and this will be an analog object. And from here, we'll generate oh, come on. New data point. Parameterize that. We do need to see what the value is. Note its type, lift station level. Okay. And so the purposes of this, we're gonna animate objects to show when pumps are on, when the pipe is full, or loaded in this case, and then when they're off. There's going to be no control. All the control should happen in the PLC. So when I turn a pump on, I'm just going to simulate the value of the level, and the level in this case may be rising, may be falling. It all depends upon the simulator. The pump will have no control. That takes a little bit more scripting, more than I have allotted time for. Okay, so we're going to add a switch to just turn the pumps on, turn them off. We'll use that with we'll use the new, or we'll use a extended widget object. I don't necessarily like the rocker toggle, so we'll change that view by looking at an extended property of that particular EWO. And now we'll put some scripting behind it that when the value toggles on, it does something. In this case, we're going to get the current value of the pump, and for the purposes of this particular pump or switch, we'll be looking at pump 1. So we're going to get that value of pump 1 state. Oh, before I do this, I need an internal variable that's going to track what our current value is. It's not int, it'll be bool. Case sensitivity is important. And then we're going to put that value, the value of that state, in our internal memory type. At the same time, we're also going to toggle that value by using a set. I won't get into what's happening behind the scenes with the DP gets and sets. We cover that in training. And now what I'm also going to do is turn on that check valve. So we'll look for it, pump 1, valve 1, dot state. Yeah. Another thing that we'll do is if the state is high, we're also going to turn on the flow values for the pipes. So we'll do a conditional check here. If not val, indicating that the value of 0 is going to be changed to 1, we need to turn on. We're going to do something. Otherwise, we're going to do something else. The first thing that we're going to do is, now we come back to the naming conventions of the pipe. And all of this information I'm putting in here is within our help file and what I'm actually doing. So here I'm actually telling it, when this is true, that flowing, how much space gets utilized by the flowing animation will be at least 50% of the actual pipe. And then I need to turn it on by indicating I want a high rate of speed. And these attributes, as I mentioned, are in the help. I also need to do it for the header, which is affectionately named pipe 3. And then in the case that it's turned off, we need to turn off both pipes 1 and 2, or 1 and 3, I'm sorry. Okay, and then we can test this. Before I do that, I want to make sure that my naming conventions are correct. Quick test. My valve didn't come on. So I'm going to look at this one again, P1, V1. That is under toggled. So station 1. And we can test that one more time. Okay. We copy this across. And then we just have to change our script to look at something else. In this case, we want to turn pumps 2 and the valve on, and then this energize this pipe and not that pipe. So we'll change the naming. Instead of pipe 1, it'll be pipe 2. And we need to turn that off as well. Test close. Now the other thing, it'd be nice for the operator to have a visual component showing exactly what that level looks like. We have another object available that can give us that visual component. And we're going to link this to the level that we set, the internal data, or the data point type, data point. Push this to the back. Test. Okay. So now here's where I cheat a little bit. I want to make this visually appealing to the end user. Before we do that really quick, let's add a simulator to make sure our values are going up and down, that our level is going up and down. And again, we're going to tie it to the lift station level. Test it. And if I turn this animation on, we get values coming up and down. All right, looks good. So now here's where I'm going to cheat just a little bit. I'm going to go back into the project that got created. It's called presentation. This is the entire project that we're developing in right now. I'm going to copy a couple of pictures into this directory for reuse. And part of those pictures will be to present the lift station a little bit more user-friendly. So we're going to change a property of the panel itself, the background property, to include a picture. Now we can do some alignment. Looks good. Let's move this over. So here we're pulling the final components of what the operator will see in runtime into a final drawing. Okay, we can move this up. Save that. Now, this is only one part of the panel. To complete the actual application, the deliverable to the end user, we need to add other things like alarm banners, alarm standards, user login, other functionality such as summary alarms. And we actually give you a tool inside the WinCC OA environment from Getty, the panel topology tool, that quickly does this for you. We can use some of the predefined templates, say pre-responsive. All of this is covered in the training. We can go through all of it. So in lieu of time, I'm just going to do these things really quick. And if you have any other questions on how these things were done, follow up in the question section. So I'm going to create a new topology. And this is our navigation topology within the OA runtime environment. Link this to a very specific runtime panel, which is lift station. Notice that when I created this new panel topology, a brand new panel got created in main. So this will be our default de facto go-to panel. And that is all I really need to do on this one. When I close this, it goes through a couple of things. It actually generates summary alerts. So we've heard the ISA 101 standard, the VDEI 3669 standard. These are alarming standards. High Performance HMI covers this in depth. My counterpart, Todd Malone, actually covered this on a previous webinar from Siemens. But what we're doing here is we're aggregating alarms from this panel topology that we just created. And the idea here is to, at no more than 3 clicks, get to the actual alarm that caused the issue with the flood alarms that we may see in an alarm viewer control. But notice that I don't have any alarm viewers. I haven't set any of the default panel topologies. So let's take a look at, really quick, I'm going to change the main splash. I realize we're running over time. I apologize for that. But we're almost done. All right. So we save this. All right. As it stands, I've created the complete runtime template or the complete runtime project. I can enable this by adding an additional user interface, but just for giggles, let's see what it looks like when I create how do I take this project and turn it into a web server project. We're going to add a manager, which is a runtime client. And we'll say manual. And as soon as I enable this particular control manager, I've just turned this project into a fully functional web server project. We can navigate to, there are a couple of different, I want to say there are a couple of different clients available to WinCC OA. In our case, we're going to look at just the HTML5 client, the ultralight client UX. And that is under localhost. So how do you spell local? /data. This is the path that you have to get to this particular thing, to get to this particular interface. And this interface has no installer because it's all an HTML5 wrapper. We go through our login. Notice I didn't add any security as I was putting this demo together. That is intrinsically a part of the panel topology functionality that we walk through. We can expand the template, look at the lift station, turn on some values, turn pumps on, turn them off. Now, part of these objects as well have built-in functions. All I have to do is click on this level function, and I can look at things like trends. I didn't build any of this into this. This is all natively, all this engineering already exists in the WinCC OA environment. We can look at additional trends. So some of these data points have a lot of functions built into them. We can look at values going back in time as well as some aggregate values. We can also, at the pump level, simulate alarms. Notice as soon as that alarm came in, I got a flood of alarms inside my alert viewer. And if I happen to not be on this particular panel that is generating this alarm, I see an alarm that comes in, and I can actually open this panel. So let's follow through this. Alarm came in, 1, right mouse click, 2. There are my 2 alarms that are active. So less than 3 clicks got us into the actual alert variable, conforming to that ISA 101 standard. So this is all part of it. This concludes this demo. It's very simple. As I said, we used a lot of the predefined stuff, and we turned it from the creation of a brand new project into a fully functional runtime engine with simulations. And with that, I will turn this back over to James, and James, Q&A.
All right, thank you, Kirk. At this time, we will address some of the questions and comments that we have received throughout the webinar. So the first one, I heard Kirk mention training. When is the next training class? Sean?
Yeah, so we typically have 1 per quarter, and we will be adding a new session that's going to happen either early October or late September, but that will be on the kaasm.com/training site, and that will be added sometime this week.
All right, thank you, Sean. Next question, is there a systems integrator partner program? Sean, this one's for you, I believe.
Yes, there is a systems integrator partner program. It is managed by Siemens, obviously. We are a certified WinCC OA training provider, so some of the requirements, we can provide all of that, and we have your email. We can send out that information if you're interested in becoming a certified solution partner for WinCC Open Architecture.
All right, thank you, Sean. In the interest of time, we'll go ahead and move on. So if we did not address your question, we'll be sending you a follow-up email shortly. So thank you, Sean and Kirk, and a big thank you to all of our attendees. As I stated at the beginning, this webinar will be available for viewing via the KAASM YouTube channel. So thank you again for your attendance. We look forward to seeing you at the next KAASM webinar. Stay tuned for details.